Okay, so we're back to do the rest of the chapter 7 examples. So let me share that screen. Let me see, I guess it's here. And once this little box goes away, I can switch it over to, oops, go away. What I need here. All right, so we're going to simplify these radicals, okay? For each of these, as I said, I like to split them up. You don't have to. So I think we did the first couple in class, but let's go ahead and do these also. Just start right from the beginning. So I'm going to split this up. Square root of 64, square root of b to the 8th, square root of c to the 12th. Okay. Then I'm going to take the square root of each one. Square root of 64 is 8. The square root of b to the 8th is b to the 4th because 8 divided by 2 is 4. And then c to the 6th for the same reason. No more square root signs, right? We've answered that question of what multiplied by itself makes this. We're just all done at that point. Over here now we have a cube root. So when I split it up, I have to make sure I'm taking the cube root of each part. All right, so we have cube root of 27. Okay, well, what that is asking me is what number multiplied by itself 3 times equals 27. And the answer to that is going to be 3, because 3 times 3 is 9, 9 times 3 is 27. Now when I take the cube root of this, similar to when I take the square root, I take the exponent and I divide it by the index. In this case, the exponent is 9, the index is 3. So x to the 3rd. And if I think about it, I can either say x to the 3rd cubed, well 3 times 3 is 9, or I could say x to the 3rd multiplied by itself 3 times, well 3 plus 3 plus 3 is 9. So that is really the answer. I can double check that. Here, the y to the 15th, I want the cube root of that. 15 divided by 3 is 5. It's kind of like a 6, but that's a 5. 3x to the 3rd, y to the 5th. Okay, here I have 5th root. Now 5th root is something, we didn't specifically talk about those, but you know what that's asking. That's saying what number multiplied by itself 5 times equals 32. What number or expression multiplied by itself 5 times, oops, sorry about that, it should be an x, is x to the 20th. What number multiplied or expression by itself 5 times equals y to the 35th. So you can put this in your calculator. Remember with that little button that may look something like this or something similar. And as we said, exponents, roots get big very fast. Exponents, I should say, get big very fast. So this is actually just going to be 2 because 2, let's say we have 5 2s. Okay, I'm just going to draw little dots so you can keep track. 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. 16 times 2 is 32. We get to this exponential expression of the variable. As always, exponent divided by index gives us our answer. Exponent divided by index gives us our answer. Okay, let's look over here. So we have 4th roots now. Now, if I look at these, I want to know, is it better to simplify them as is, or is it better to multiply them together, which I can do since they're both 4th roots? Well, the 25 we might not know right away. But when I look at the x's, 3 is not divisible by 4, and 10 is not divisible by 4, and 9 and 14 are not divisible by 4. So those certainly are not perfect fourths. So let's go ahead and multiply what we have here, okay? And when we do that, it's going to end up in a 4th root still. So 25 times 25, this gives us 125. This gives us 5 times 2 is 10. 2 times 2 is 4, plus 1 is 5. This is going to give us 625. So we're going to have 625 x to the 12th, y to the 24th. Okay, so again, if you want to split it up, we're taking the 4th root of 625, the 4th root of x to the 12th, and the 4th root of y to the 24th. So 4th root of 625, again, you can use that root button on your calculator, you can also kind of guess and check by starting out with some numbers, taking them to the 4th power, see if they end up being 625. This is actually going to be 5. As I said, things get big very fast. So even with what seems like a big number, you won't have to try very much. So 5 times 5 is 25, times a third 5 is 125, times a fourth 5 is 625. For these two, just like always, exponent divided by index. Exponent divided by index. So x to the third, y to the 6th. All right, on to the next one. Again, you know that we can, whatever works better, we can simplify, take the square root of the top and the bottom separately, or we can put them together. Well, again, 32, 8, and 8 are not perfect squares. 10 is divisible by 2, and -4 is. But since these are not perfect squares, let's go ahead and combine them so to see if we have something better. Well, 32 divided by 8 is 4, so that looks better because that is a perfect square. And then I'm using the quotient rule here, so 10 minus -4 is 10 plus 4, which is 14. So x to the 14th. Again, if you want, you can split it up. Square root of 4 is going to be 2. Square root of x to the 14th is x to the 7th. All right, multiplying here, we have, now this is not a second root and a fifth root, right? This is just 2 times the square root of 6x times 5 times the square root of 24x. So what happens here is these outside numbers can get multiplied. So 2 times 5 is 10, and then the inside numbers can get multiplied. So 24 times 6 would give us, let's see, 144, so 144x squared, right? X to the first times x to the first, I add those exponents. So this 10 is just a plain number. It's getting multiplied by the square root of 144 and the square root of x squared. So this is 10, square root of 144 is 12. I'm just putting it in parentheses to show that these two have to be multiplied, and I can't just have 1012, right? And then square root of x squared is x. Doesn't really need to have parentheses there. So I have 120x altogether. Okay, the next part we talked about in class about taking roots, and then here are some here at the bottom that are not perfect roots. So we can't simplify it down to just something totally out of a square root, but we can make it a little simpler. So we did this one in class, but what we're thinking about is we want to find the biggest perfect square that is a factor. So radical 50 is not an integer, right? It would give us a long irrational number that's a decimal that goes on and on. But we said if we can think about factors of 50, 25 is a factor. If you're not sure, think about how we do factors of a number, right? Write them out really neatly in an orderly way. So I have 1 times 50, 2 times whatever it is, 3 doesn't go into it, 4 doesn't go into it, 5 times 10, and then 6, 7, 8, and 9 don't go into it. 10 does, but I already have that, so that would be a repeat. All right, so of these, I only have one perfect square, so I want to split it into this grouping. I want to write my perfect square first, because now I can take that perfect square. It's 5. I can't take the perfect square, or I can't take the square root of 2. It would be 1 point something. I don't want to have a decimal that I have to chop off or round off somewhere, so I'm going to leave it as radical 2. Okay, let's look at this one. So we have the square root of 32, the square root of x to the third. So let's take each one separately. So 32, if I think about factors of 32, I have 1 and 32, 2 and 16, 3 does not go into it evenly, 4 and 8, 5, 6, and 7 do not. So I have 2 perfect squares here, okay? The best thing to do is to pick the bigger one. Otherwise, I'll just have to simplify it a second time, and you might miss that. So I'm going to say that 32 is 16 times 2. I put the perfect square first. This is going to become 4 radical 2. Let's see about over here. Well, 3 is not divisible by 2. My exponent is not divisible by my index, okay? If I think about x to the third, it's x times x times x. I need a number of x's that's divisible by 2. Well, if I have 2 x's, if I have x squared, That is going to be divisible by 2, and then I'd have 1 left over. Okay, that's the most I can have that's divisible. So I'm going to rewrite it like that, x squared and x to the first. This one is not a perfect square, this one is. 2 divided by 2 is 1, and then I have my radical x. Okay, so in each case, I split them into something that's the biggest perfect square factor I could, and then the other part just had to get left in the square root. So 4 times x is 4x. Those outside numbers can get multiplied, and then the inside numbers can get multiplied. So radical 2x. All right, let's look at these. And again, I want you to pause the video, try it on your own, okay? See what factors of 250 would be a perfect cube. See how you can split up x to the 5th so it has the biggest amount that's divided by 3. Okay, so I'm going to rewrite them like this. If I think about factors of 250, I'm going to find that 125 times 2 is a pair of factors, and 125 is a perfect cube. 5 times 5 times 5 is 125. So I have 5 times the cube root of 2. For this one, again, think about I have 5 x's. I want to make the biggest group where the number of those is divisible by 3. So I can make 3 of them, right? And then I'm going to have 2 left over. So it's going to be cube root of x to the 3rd times the cube root of x squared. This is a perfect square. It becomes x. I have the cube root of x squared. Okay, 5x, so these get put together, and then these get put together. Cube root of 2x squared. And these are a little tricky, okay? It might take you a few times looking through the video or trying it on your own to really get the hang of it. But you're breaking them up and finding out the biggest perfect square that you can take out if the whole thing is not a perfect square. Okay, so I just split it up. Square root of 18, square root of a to the 7th, square root of b to the 3rd, square root of c to the 8th. Square root of 18, okay? I will let you think about what the factors are, but the biggest perfect square factor is 9. So this is going to be 3 radical 2. A's, a to the 7th. I want a number here, the biggest number I can, that's divisible by 2. Well, if there are 7 a's, the biggest section I can take is 6 of them, right? 6 divided by 2. So I'm going to take radical a to the 6th and radical a. So this is going to be a to the 3rd radical a, 6 divided by 2. Here again, I want the biggest chunk that's divisible by 2. So b squared times b. B squared is a perfect square. That's just going to be b, so b radical b. C to the 8th actually is a perfect square, right? 8 is divisible by 2. So now I'm just going to collect everything that's outside of a square root and write that together. So 3a to the 3rd, b, c to the 4th. And then in the square root, I have 2a, b, right? I have this one, and this one. So it looks like a lot, lots of little parts, but if you take each part, you've done each part before. You know how to do that. All right, so that's the end of those examples on chapter 7, okay? Again, I apologize that it took me a few days to get them up. If you need a little more time on the homework or notes because of that, just let me know, okay? I will talk to you guys later.